Okay, so now Safi, Akmal, and Masna find 3 ropes tied together with a single knot and decide to have 3-way tug of war. Masna pulls to the west with 100 Newton of force, whereas Akmal pulls to the south with 200 Newton. How hard and in which direction should Shafi pull to keep the knot from moving? Okay, first of all, we draw out the situation here. We always draw out the situation. Okay, so we have Shafi, Akmal, and Masna. So this 100 Newton force is by Masna. We put like this. We put maybe you put the numbers. Yeah, Shafi is number 1, Akmal is number 2, Masna is number 3. Okay, so we put the 100 Newton is by Masna. So this one we put as F3. Yeah, F3. Akmal is number 2. Akmal is number 2. So this one we put as F2. Okay, more systematic. Yeah, F2. Shafi is number 1. So we need to find F1. We need to find F1. That means we need to find how hard. How hard in which direction. That means we need to find both. How hard means find the magnitude. And in which direction, that means we will need to find direction. Okay, that means for F1, yeah, we need to find F1. Yeah, the magnitude and direction of F1. So draw out the situation. First of all, I need to draw the axis. Yeah, I need to draw axis first. Okay, let me draw out the axis. So this is the x-axis, and after that we have the y-axis. Okay, hold on a second. We need to draw out the y-axis also. Okay, so that's correct. So now this is the x and y-axis. So where is the F3? Okay, F3 is going to the west. Going to the west. So do you know the direction northeast southwest? Northeast southwest. Okay, this is the north. This is the south. Northeast. East is here, and this is the west. Okay, northeast, southwest. So Masna pulls to the west. That means to the left. Yeah, actually to the left. 100 Newton force. So let's draw it out. Yeah. So Masna pulls to the left. Okay, how do I draw it? I use I pulls to here. This is Masna. Pulls to the west. So this we put as F3. This is F3, which is 100 Newton. Okay, 100 Newton. And then Akmal, which is F2, 200 Newton, it pulls to the south. Oh, what is this? Okay, Akmal pulls to the south, which is 200 Newton. So it is this one. Pulls to the south. Yeah, goes to the south, 200 Newton. So yeah, this is F2. It is 200 Newton. Okay. Now Shafi should pull what direction? So to keep the knot from moving. So actually, he says here, keep the knot from moving. To keep the knot from moving. So this is implying equilibrium. Which about the Newton first law, isn't it? Newton first law, talking about equilibrium. When about equilibrium, that means keep the knot from moving. So initially it's not moving, right? The knot is not moving, and then to keep it from not moving, so the velocity 0, velocity 0 to keep it from not moving. So it is equilibrium. Equilibrium, that means the total force must be 0. Total force must be 0, equilibrium. And there are two things under total force equal to 0, which is the x component force is 0. The y component force also 0. This is equilibrium. Equilibrium, that means the x and y component both total force equal to 0. Yeah. Unlike, what is this? Okay, unlike the earlier example, which has a resultant force, this is not equilibrium because it got resultant force. You see that? It got resultant force. It got the resultant force. That means this is, for this one is not, this one is non-equilibrium. Non-equilibrium. Because we have resultant force. Because we have resultant force. Okay, this resultant force equal to ma. Surely it has acceleration in certain component, either in x or y component. Okay, so this is not equilibrium. Okay, maybe I should write not equilibrium. It is not equilibrium. Okay, make it black. This is not equilibrium because we have because we have what? We have resultant force. Yeah, not equilibrium because we have resultant force. And when we have resultant force, we must have acceleration. The acceleration is not equal to 0 because the resultant force is not 0. Okay, when resultant force not 0, acceleration also not 0. So not equilibrium. Okay, not equilibrium. So to find the resultant force, this is the way we find. Find the total fx, total fy, and then just Pythagoras theorem. But for this question equilibrium, questions, a bit different. We also need to draw table just like the resultant force, but we need to change a bit how to find the balance force instead of finding the resultant force. Okay, let me show you. Let me show you. This is just now, this example is about not equilibrium. Now this example is about equilibrium. Equilibrium. So how going to do these questions? So we can actually predict that Shafi, which is F1, should pull around this direction. F1 should be around here. We just don't know what is the angle, isn't it? We just don't know what is the angle theta and what is the magnitude of F1, so that the knot at the center, this is the knot. Okay, this center, this is the knot, will be not moving. The knot remain at the same position. To keep it from moving. To keep it from moving. So that means we can say this whole system is in equilibrium. So we need to find this F1. This F1 can sometimes be called balance force. The balance force. What is the balance force? The balance force, this is the force by Shafi. Okay, this is a force by Shafi. This just now the this one F3 is by Masna. This force is by Masna, and the F2 is by Akmar. This is the force by Shafi to balance this knot from moving. So this is the balance force, so that with this balance force, the total force is equal to 0. So that the total force is equal to 0. With existence of F1, so the total of F1, F2, F3, the total of all these forces equal to 0. And also the total in x component, is 0. Total in y component is also 0. This is what we call equilibrium. This whole system is in equilibrium. Equilibrium. Understand or not? The example just now is not equilibrium. Example just now, this one is not equilibrium. Not equilibrium. It will move somewhere. It will accelerate in some direction. It will accelerate in this direction. You see, because the resultant force is here, above the 33 degree above the positive axis. So it's not equilibrium. This one is this system is we can say just copy it here. It's not equilibrium. This system is not equilibrium. This this Masna, Shafi, this type of what, this one is in equilibrium. Yeah, just now this example which I explained already, this one is not equilibrium. It will accelerate in the direction of resultant force. Resultant force is in the direction of 33 degree above positive axis. So this system, it will accelerate this way. It will accelerate this way. Yeah, it will accelerate in the direction of the resultant force. Okay, because we know that the total force we calculated here, the resultant force, which is 0.714, is equal to MA. It got the acceleration. Understand or not? It got acceleration because we have resultant force. Okay? As acceleration, so it's not zero. Yeah, it's not zero. It will accelerate in this direction. So now this one is equilibrium. Yeah, it will not go anywhere. Yeah, it will not go anywhere. Oh, sorry. It will, the acceleration here is equal to 0. Yeah, because the resultant force is 0. Yeah, because the resultant force is 0. So now the question is how to find this F1. How to find this F1? So we actually do the same thing like this. We use table also. Yeah. So let us do it. Yeah, let us do it. Let us do it one by one. Okay. I put the table over here. A very useful table. Yeah. So same thing we also do. You know, we fill in the x component and y component. So we put here F1. Okay, maybe F1. Okay, F1. This is and then we have F2, F3. Okay. Remember this. The F1 is actually the balance force. Is the balance force. We can put it as you know. Hold on a second. Yeah. We can put it as maybe you can put it as FB. FB means balance force. Okay. So this FB we don't know yet. What's the force? So maybe we just put as F1. We just put as F1x. This one is F1y. F1y. Okay. F1y. Okay. So how to find it? Yeah. F1x and F1y. So okay. Okay. So F1y we don't know what is the force we need to find lah. Okay. F2 we have already. F2 is going downward. Another thing is we need to put the direction. Going to the right is positive. Going to the left is negative, isn't it? Going upward is positive. Going downward is negative. Don't forget that. Don't forget that. So okay. So now Akmar F2 going downward. So it only has a y component, no x component, right? So no x component, so the x component is 0. But the y component is negative. Going downward is negative. So put as negative. Negative what? Negative negative 200. Okay, no angle. The 200 is totally in y component. So going down is negative 200 over here. Now F3 is only x component, so no y component. So y component we put 0, and then this x component F3 is going to the left. Going to the left is negative, so we put as negative, negative, and then this is negative 100. Okay, negative 100. So and then finally we want to find the resultant force. The resultant force is equal to what? Remember equilibrium? About equilibrium, total Fx is equal to 0. Total Fx is equal to 0. Total Fy equal to 0. Last time, when doing the resultant force, we have total Fx and total Fy is not equal to 0 because not equilibrium. Not equilibrium, we have total Fx and total Fy. Yeah, we total up all this and total of the x, we got the resultant Fx. Total of the Fy, we got the resultant Fy. But now this is not equilibrium. This is not equilibrium. Now it's equilibrium. If equilibrium, when we total up all this, including the unknown f1, we get total fx equal to 0. We total up, including the unknown f1y, we get total fy also equal to 0. Because why? Because we know that the total because we know that the total f equal to 0. When the total f equal to 0, that means total fx equal to 0, total fy also equal to 0. So here we can build equations. You understand? Here we can build equation. That means we total all this equal to 0, total all this equal to 0. So here we have two equations. It's the same thing like before, yeah? Just same thing like finding the resultant force, just that the resultant force now is equal to 0. So it is F1x, this is actually the balance force, plus 0, and then plus the negative 100, okay, plus the negative 100 equal to 0. Yeah? This is actually the total fx, understand or not? Total fx equal to this total up, we get 0. The total fy also equal to, total fy is total all this f1y plus the negative 200 plus the 0, we get 0. Total all of them, we get 0. So we can find, from here we can find the f1x. You can find f1x. So this one go to the other side, become what? Positive 100 Newton. And then how about the f1y? F1y we f1y we this one go to the other side, we get what? We get positive also. We get positive what? Positive 200 Newton. Okay, so it's correct. You see, seems like the direction is going as expected. F1x is going to the right because it's positive. F1y is positive. F1y also positive, means going upward. It's going upward. So yeah, that's correct. F1 is really going in this direction, going to the right and going upward. You see that? Going to the right and going upward is correct. Yeah. So it's going as expected. So now let's find out the f1y. F1. So now we draw again. This is f1. This is f1x, which is okay. Again, f1. This is f1x, which is positive, and this is the f1y, which is also positive. Okay, which is also positive. So this Pythagoras theorem, we got the f1. This is the f1. So how to find the f1? Okay, Pythagoras it. We get f1. So, and this is the angle theta we need to find. So Pythagoras, that means we also use the f1x, square it, and then f1y also we square it. And what's the answer? Yeah, after square root. Okay, it is 223.61 Newton. Okay, and then what's the direction? This is the question. How hard Shafi pull? This is the balance force, yeah. And we also can say this is actually the magnitude of the balance force. The balance, so that become equilibrium, yeah. And then find the direction. Come on, find the direction. Tangent theta equal to also we take the f1, the y component, f1y divided by f1x. Okay, so and then don't forget to anti-tangent. Yeah, anti-tangent. And also don't forget to modulus it. We only want the positive value. The angle must be small. So what's the answer? I got it is 63.43 Newton. No, degree. This is angle, not force. This is angle, not force. This is above the positive x-axis. You see the direction? It is above the positive x-axis. So you must write there, above positive x-axis. So it's correct. Yeah. So this is in what direction? We got the direction already. Okay. So just now the F1 here. Okay, we got the answer. This F1 is okay. We can write it down. This F1 is actually 223.61. This actually is 223.61 Newton. And this this one just want to is too disruptive. I just want to make it the other place. Yeah. Yeah. Okay. Right. This to keep it from moving. Yeah. So F1 is 223.61. And how about the angle here? Okay. Angle here is what is the angle here? 63.43. Yeah. So this angle is 63.43 degree. This is the balance force. This is the balance force to balance it so that total F equal to 0. Total F equal to 0. You see that? The resultant force, total Fx equal to 0. Total Fy also equal to 0. We just need to find this balance force. These two are the balance force. The balance force. Yeah, these two are the balance force. To balance all the force becomes 0. This is what it means by. This is what it means by equilibrium. This is what it means by equilibrium. When equilibrium, this total Fx and total Fy and the total F all must be equal to 0. Must all equal to 0. This is the balance force. Sometimes you can write it as instead of writing F1x, we can write it as balance force FBx. This one, instead of we put F1y, we can write it as FB. Yeah, we can write it as FBY. Yeah, this is FBx, this is FBY. Okay, so that's it. That's it to find the balance force for equilibrium conditions. Okay, so hope you understand and like my channel, and don't forget to subscribe and like and share. Thank you. Bye.